Hello, this is Will, and I'm going to demonstrate how to test, right? Test validity of an argument using a truth table. Um, that's going to be on page 322 of your book, and this is going to be um, section C, just to be clear about that. Okay, so let's try to get started here. So number one says something like, if Angola achieves stability, then both Botswana and Chad will adopt more liberal policies, but Botswana will not adopt a more liberal policy, therefore Angola will not achieve stability. So the way I'm going to represent that is if A, then both B and C, and I treat the word both as the parentheses. Then I'm just going to draw here not B for Botswana will not adopt liberal policies. And then I'm going to use our traditional little tri-dot predator symbol from the movie Predator for the conclusion not A. And I want to test this in a truth table. So let's see here. How many different letters of the alphabet do I have? Well, um, it actually looks like I might have uh, five. You know, if you conclude, so if you include the ones with the tilde here, might look like I have five, but in fact, I do not. I only have three. I have A, B, and C, right? So I have A, B, and C. So when I construct a truth table, um, that means I have three of those. So n equals 3, right? So that means when I do 2 to the n, I get 8. Oops. I do 2 to the n where n equals 3, I get 8. So I'm going to go ahead and try to construct that truth table to determine validity. So let's see how we would do this. First, I would draw my variables over here. Draw a line there. B. Okay, and then C. I'm going to draw another line just like that. All right, let's see here. So I'm going to need 8 rows. So 1, 2, 3, 4, 5, 6, 7, and 8. Okay, so I'm just trying to keep it a little neat here for you so it's not like a complete train wreck with my handwriting. So then I'm going to have to outline the premises, but we need to break these premises into smaller parts. So the first thing we look at is if A, then B and C, right? It looks like we have right here, this B and C, that's a smaller part, right? So we have A, which is already listed over here, and we have B and C that we need to list, right? So let's go ahead and try to just draw this. Let's see here. B and C, right? And we'll just extend these lines out here a little to make it a little bit clearer, with the truth values. So we got B and C. And let's see, I'm just going to make sure I get all these in here so there's no confusion which row goes where or whatever. In fact, I'm just going to redraw this a little bit. With B and C. Now, obviously, you need to know how this little function symbol or this little binary connector is defined. So you need to know the conjunction definition to even be able to do this, obviously. But let's go ahead and fill in some truth table rows. So for every one true here, we need one false. because it's in that first row. So true, false, true, false, true, false. Then in the second row, we're going to need for every two t's, two f's. So two f's, oh, two t's. And what this does is it gives us all possible combinations. So now for every four t's, we need four f's. Okay, so now we do our f's here. Geez, this is a lot of work. Okay, so let's look at this and okay, so now we're thinking about B and C, right? B and C is true only when both conjuncts are true, and it is false otherwise. All right, so here you would see that B and C is true, so that's true. You'd see that that's true again, and then well, one of them's false, so we know that's false. One is false again, and it's going to be false all the way down. So, whoop. Let's just do that a little clearer. Okay. So go ahead and do if A, then B and C, since we now have B and C. So I'm just going to draw this in a different color. Sorry if that's a little confusing. So if A, then B and C. Just draw this line here. Try to get some straight lines here for you. It's a lot of work. I really feel you. Really feel for you when you're in an exam trying to do this quickly. I mean, this is it's a task doing this quickly and neatly, and got to be legibly, and you got to get the logic right. Okay, so we know by our rules of the if-then that the only time that this horseshoe is false is when the antecedent here is true and the consequent is false, right? So that's the only time this whole thing is false. Just keep that in mind because it's true otherwise. I'm just going to go through it real quick. So here I see A. A is true because I'm looking to my far left. And then I see that B and C is true. So that's true. And I know that when the consequent is true, that it's always true. So my consequence is true there. My consequence false here. So, looks like it's false there. And then looks like it's false here as well. And true, true, true. Oh, what is going on with my pen here? All right, so true and true. Okay. Yep, so looks like it's true there. But now what do we do with these the conclusions, right? Well, so how do we operate with these negations? Well, this all negation does is it inverts truth value, right? That's all negation does. It flips the T's and the F's. So we already have B over there. So I'm just going to extend the lines really quickly. I would not recommend just trying to do this in your head. On an exam, you could really mess up, and you don't want that. So this is going to be false. This is going to be false. Let me just do a different color. All right. This is going to be false. This is going to be false. This will be true. This will be true. This will be false. This will be false. This will be true, and this will be true. So now we want to do not A. That's our other line here. So separate these with some lines real quick. Oh man, I've really got to start working on this pen, man. I'm bad with the pen sometimes. I'm gonna change colors again. So we're gonna do 4. Oh, dear heavens. All right, let's see here. See if I can. There you go. All right, so true. Oh no, sorry, it's true over there. So we'll make it false here, false there, false there, false there, true, 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 and true. That inverts our values, and so A is going to be the overall conclusion of the argument. So this is going to be the overall conclusion is marked right here. That is our conclusion. And so remember, we want to find a row where, if it's invalidating, where the premises are true and the conclusion false. Well, I'm going to give you a little sneak preview. This is a valid argument. So there will be no row where the premises are true and the conclusion false. So here, let's just look. Here, these 4 rows are the only ones you have to worry about. So we don't have to worry about these, right? So we don't have to worry about these. Now, I'm not doing a short. We don't have to worry about those, right? And we don't have to worry about those. So it looks like all we have to worry about is this row, right? So true, and those 2 are false, we already know. So we know that's safe. And over here the same. We got 2 false, 2 false right here, 2 true right here, so it doesn't even matter. So there's no invalidating row. No invalidating row. Sorry, I can't spell that too well. So that is how you determine the validity of an argument with the truth table. I hope that was a little bit helpful and not too painful.